I may or may not have forgotten to record the beginning of this stuff. I think that I did forget to record all this stuff. I'm sorry, guys. We plugged in the values, we made conclusions with the extreme value theorem. We saw that if it's not continuous, then the extreme value theorem doesn't apply. And then we said if we change the interval to a thing where it is continuous on that interval, then the extreme value theorem does apply. We applied it. And then we've been talking about how the second derivative test gives us information about concavity. So sorry, I forgot to record all that, my bad. Okay, so are there any questions about what this concavity test is telling us? Okay, and we're just gonna make one definition, put some guidelines down, and next class, that way we'll have all of this in our notes and we'll be able to just go straight into doing problems with the concavity test. Because I did get a little bit behind today, probably because of my internet situation. Okay, so where a function changes from concave up or concave down to concave down or concave down to concave up is what's called an inflection point. The values where f of x change concavity are called inflection points if f of x is continuous at those values. So in other words, if I have a thing that goes from sad and then it changes over to happy, my inflection point would be right there where we're changing concavity. But if I have a thing that changes at a discontinuity, that's not considered an inflection point, it's just considered a discontinuity. Okay, so these are my inflection points. So it turns out that inflection points will only occur when the second derivative equals 0 or doesn't exist. So these values where f double prime equals to 0 or f double prime does not exist are called potential inflection points. Not critical values, but potential inflection points. Which you will hear me refer to from now on as PIPs. Okay, so we're gonna end there today so I don't keep you late. We kind of have some information about the second derivative now. We have some new definitions. Next class, we're gonna actually do examples where we, again, talk a lot about solving equations, but also use that in the context of the second derivative. Are there any questions before we finish?